Hey everyone, and welcome to This Explainer. Let's jump right into the beating heart of Windows Server 2019 networking by looking at the ultimate master address book of the internet, DNS. If you've ever wondered how data actually finds its way across a massive network without getting hopelessly lost, well, you are in exactly the right place. In fact, DNS failures are famously responsible for some of the absolute biggest global internet outages in history. So, we're going to break down this vital infrastructure step by step so you can totally master it for your own environments. To really get why we even need DNS, we have to look at a pretty fundamental problem. How did humans and machines actually talk to each other? See, as humans, we speak in friendly, memorable names, like IT4U.N or Google.com. But computers, they only understand strict numerical values, like an IP address of 172.16.x.x. So how do we bridge this massive communication gap so that when you type a name, your computer knows exactly which numbers to dial? Here's our roadmap for today. We're going to cover the network's master translator, forward and reverse lookup zones, primary versus secondary zones, Active Directory integrated zones, and finally, decoding essential DNS records. All right, kicking things off with Section 1, the network's master translator. Let's look at how our network translates languages right at the foundational level. The domain name system, or DNS, is literally a massive digital phone book. I mean, you don't memorize a friend's 10-digit phone number, right? You just tap their name in your contacts. DNS does the exact same thing for a network. It takes that friendly, human-readable name you type into a browser and instantly acts as a translator, returning the precise IP address needed to make a successful connection. Without it, the internet as we know it, and specifically your internal enterprise network, simply wouldn't function. Every single Active Directory authentication request, every shared folder access, relies heavily on this translation happening flawlessly in milliseconds. Moving right along to Section 2, forward and reverse lookup zones. Let's see how this builds into the two main folders of our address book. So there's a really clear distinction between the two main types of zones you'll configure in Windows Server 2019. Think of them as two separate directories. The forward lookup zone is the one you'll use most often. It gives you the numerical IP address when you query a name, like Google.com. Pretty straightforward. But sometimes a system needs to verify who a specific number actually belongs to, and that's where the reverse lookup zone comes in. It does the exact opposite, toking an IP address and resolving it backward into its assigned host name. For instance, if you're an IT admin hunting through security logs that only show raw IP addresses, you're going to rely heavily on reverse lookups to identify the actual machines involved. Which brings us to Section 3, primary versus secondary zones. Now that we have our folders, we absolutely need to ensure they're backed up and distributed properly. Look, if you only have one single copy of your address book and that server tanks, your whole network goes blind. Poof. That's exactly why we divide responsibilities. Think of the primary zone as your master document, where all the editing happens. It is the authoritative read/write source of truth. The secondary zone, on the other hand, is essentially a read-only photocopy of that master document. It gets distributed to other servers to provide load balancing, so one server isn't doing all the heavy lifting, and crucial fault tolerance to keep things running if the main server crashes. You actually can't make changes directly on a secondary zone. It quietly syncs up with the primary through a process called a zone transfer, actively querying the primary server to pull down the latest photocopy of the records. To actually build this master copy in a standalone 2019 environment, you follow a pretty strict logical flow. Step 1, and this is absolutely critical. You must assign a static IP address to your network adapter. A server's identity shouldn't be shifting around, otherwise your clients will literally lose their roadmap to the network. Step 2 is adding the DNS server role right through the server manager. And finally, Step 3 is opening up the DNS manager to manually create your new primary zone and begin adding your host records one by one. All right, let's jump to Section 4, Active Directory integrated zones, because in a large enterprise, managing thousands of records by hand is just an absolute nightmare. This is where the real power of Windows Server comes into play. If your DNS is installed alongside an Active Directory domain controller, your address book becomes beautifully self-updating. When you use an Active Directory integrated zone, machines automatically log their own IP addresses and names right into DNS the moment they join the domain. Even better, this process enables secure dynamic updates. That means only authenticated machines can update their records, which stops rogue devices from maliciously overwriting critical DNS entries. It adds a massive layer of enterprise security. Plus, it drastically reduces your administrative overhead.
Because, well, you aren't stuck typing out manual updates every single time a laptop moves to a different floor.
Finally, Section 5, Decoding Essential DNS Records. The crucial point here is understanding the specific rows inside these zones that make the whole system tick. So, the very first entry automatically created in any zone is the Start of Authority, or SOA record. Think of this as the boss record. It contains a serial number that actively tracks database changes. Think of this serial number as a version stamp. If the primary server's serial number is higher than the secondary server instantly knows it's time to pull an update. The SOA also dictates all the critical timing rules, like the standard 15-minute refresh interval that tells secondary zones exactly how often to check back in. Before we dump the rest of the records on you, let's look at a super common IT scenario. Imagine trying to force your end users to memorize a ridiculously long, complex server name, like IT4U-DC01-prod, every single time they wanted to connect to a company portal. Your help desk phones would be ringing off the hook, and your users would be endlessly frustrated. And that headache right there is exactly why we use a CNAME, or canonical name record. A CNAME acts as a friendly alias, or a nickname, that points back to that complicated true server name. So you can create a simple intuitive CNAME like mail or tech, and DNS will automatically reroute that easy-to-remember alias directly to the underlying IT4U DC01 prod machine without the user ever even knowing. Consider this your ultimate DNS record cheat sheet, mapping out the absolute essentials. Your host A record, that is your bread and butter, mapping a name to a standard IPv4 address. Moving to modern networks, the quad A record handles the exact same function, but for IPv6 addresses. We just saw the CNAME in action for creating those friendly aliases. And finally, the PTR, or pointer record, which lives exclusively in that reverse lookup zone we discussed earlier, mapping an IP address backward to a hostname. Now here is a real-world troubleshooting trick that will honestly save you hours of headaches. Sometimes you'll manually add a new host A record on your server, but when you jump to your client machine and try to ping it, it completely fails. Why? Because the client machine has memorized the old dead IP address in its local memory cache. You've got to use the command prompt and type ipconfig/flush DNS. This instantly clears out that old cache, forcing the computer to reach out and actually read the new updated address book. So, we've covered the translator, the zones, and the critical records-keeping enterprise data flowing. But as we wrap up this explainer, I want to leave you with a critical fault tolerance question to ponder as you design your own highly available environments. If your primary DNS server goes dark right now, is your secondary zone actually configured and ready to catch the load, or will your entire network go blind? Thanks so much for joining me, and keep exploring your infrastructure.